I
Okay.
thought that that's likely to be on Mike's agenda.
That actually wasn't on the list, so we can absolutely do that. Why don't we start there?
Well,
So do you want to get the ball rolling then, Chris?
no, I think we left it with your statement that it was uniqueness of behavior that counted. And
Yes.
I was just going to raise basically the same question of how unique does behavior have to be to count as unique? And with humans, that's kind of easy to answer. But with other systems, it seems more difficult to say what counts as a unique behavior or a novel behavior. And certainly as one goes down into the cellular scale, or the scale of unicellular organisms, it becomes a lot more difficult, I think, to say what counts as a novel behavior, although it may be an old behavior executed under novel circumstances or something like that. Like, Mike's barium worms example, where they're doing something familiar, but they're doing it in previously unencountered circumstances. Perhaps that would render it a novel behavior. I don't know whether that fits within your idea of what novelty is.
Yeah. Well, let me say, first of all, that as always with you two, it's not a matter of, what my definition is, because my definitions change all the time in response to conversations with the two of you. So it's not like, let me state how it is, so much as let me throw my hat into the ring. But I doubt it'll come back in the same shape, because I think these sorts of questions are they're at the frontiers of what we need to think through. I don't think that any of us has a really satisfactory thoroughgoing formulation of what view we should take on it. The second thing I wanted to say is that when you said, well, it depends what you mean by novel, it's clear at the human level there's lots of novelty, but as you go to simpler and simpler organisms, it becomes more difficult. I think that's also what is to be expected. Both the obvious that it's that there's more novelty with us and less novelty as you go to simpler organisms, but also that it's a graded capacity. It's not either it's present or it's absent, and of course that applies to consciousness too. It's very unlikely that there's suddenly at some moment in biological time there's a dawn of consciousness. It's more some sort of something that's edging towards that, something which possibly qualifies to be that, and then eventually you think no. So it's a matter of degrees of confidence, if you'll excuse the pun, in whether or not what you're looking at is actually meets the criteria. So with those preliminaries out the way, what I was saying in the emails is that if an organism responds to a novel stimulus with a behavior or an action, I suppose I'm using the word behavior very broadly to include any response. If it responds with a behavior that is within its phenotypic fixed phenotypic repertoire, then there's two ways of interpreting that. The one is that it has recognized an analogy, which implies intelligence. It's a thought process of some kind, an inference, rather, I should say, or alternatively, it's a mistake. In other words, it is misidentifying this stimulus as the other stimulus, and it's therefore giving the response that it would give to the other stimulus, which just happens to be the right one, or which it's within the same ballpark, and that's why it triggers the same response. All sorts of possibilities flow from that. This last thing that I've just said, because there too, there's, for example, let me say, for example, it may be that there's a range of responses, 9 out of 10 of which are completely erroneous, and the organism therefore expires. One of them randomly happens to be the right incorrect response, if you know what I mean, the right mistaken response, a mistaken response which does work, and then that that organism survives. So it would be a matter of, are what we're seeing there is just something to do with with random variation, which is how natural selection works. Now there's an increased chance that the offspring, the descendants of that 1 out of 10 of that species will always do the right thing in that situation. That's one other issue that comes up, and I think why I mention that is I think that the mechanism I'm going to specify now stands in contrast to that, because what I think the adaptation is, the adaptive advantage is of the mechanism I'm going to describe, is that you don't need to rely on natural selection. You can actually learn from experience, underlining the word experience. You can learn from experience during your own ontogenetic development. And that is a huge advance over having to lose a great proportion of the species, so that the ones that just happen to do the right thing can survive and propagate. And now is the mechanism that I have in mind, the alternative to the natural selection, the phylogenetic mechanism. It is that the organism encounters a novel situation, a novel stimulus or a novel problem, and at that point, its determined behaviors fail it. In other words, its reflexes, depending on how complex a creature we're talking about, you might say its reflexes, its instincts, everything that pre-exists in its behavioral repertoire is of no use to it. So at that point, a purely determined kind of response has to be replaced by something more in the nature of, or either is replaced by what I was saying earlier. In other words, they die, they make a mistake, or they randomly do the right thing. Rather than all of those, it behaves in a stochastic fashion, but not just stochastic fashion, because it has affect. So it does various things, and it is able to register which one of these is working best, because the need is the problem posed. I now don't have a solution to this situation. I'm in a state of need. Okay, this behavior is meeting the need. This behavior is not meeting the need, nor is that, nor is that, nor is that. So I'm going to carry on doing this. I think that's the fundamental contribution made by affect. And you can see from what I'm saying is it underwrites choice, it underwrites voluntary action, because it's not just random. It's initially, I'm in a panic, I don't know what to do, but I can feel my way through the responses that I'm generating. I can feel which one is working, and that in turn leads to learning from experience. And now you have an additional arrow to your bow the next time that you encounter this situation. It's now a situation for which you do have a prediction. But so that is the moment of suddenly expanded sort of degrees of freedom, and the navigation of that situation is what feeling contributes. It's sort of it provides value. The value being survival is good, death is bad, and it allows you to register within that system of values. That's what feelings do. Register within that system of values. And I would only add one other thing, which is that it's not just goodness and badness. It's goodness and badness within multiple categories of need. So it has a valence and it has a quality. That's the mechanism that I tentatively am proposing, is instead of the earlier ones, this is something else. And that's where I think, so it's, that would be my behavioral criterion for feeling reasonably confident that what I'm seeing is an organism which is using what we call feelings to solve a novel problem.
So it sounds like what you're proposing is a kind of general purpose analogy mechanism with affective response, some form of confidence that this will solve some kind of problem as the criterion for picking a good analogy.
I suppose, I wouldn't have thought of putting it like that, but as you say that, I can see why you say that. That does make sense. But I'm glad you mentioned the issue of confidence, because I don't know if you remember in my very rapid presentation in Boston, I spoke at the end about the importance of precision, of palpating and modulating of confidence. So the affect, remember, it is not just valence, it's valence within a category of need. So you're feeling increasing or decreasing, let us say, a suffocation alarm, and let's say the increase in the suffocation alarm gives you less confidence in your current policy, in the thing that you're doing, and so you have increasing confidence in the error signal, that is the affect, and you have decreasing confidence in the action, and so you change your mind, you do something else, and that once that leads to increasing, once that leads to decreasing, the affect is now moving in a positive direction. In other words, decreasing suffocation alarm, decreasing respiratory distress. Now you have more confidence in that policy, and that in turn, a high precision situation like that drives the updating of the predictive model.
I wonder, I was thinking earlier this issue of what counts as a novel behavior, and I wonder if we should lean more heavily on the notion of an observer here, from the point of view of a novel behavior is one that you as an observer of the system, and then we can say, oh, by the way, also the system itself, right, is surprised by it. Could we close the loop that way and say that a truly novel behavior is one that surprises some observer, and that may be a scientist, that may be some metacognitive module in the system itself, but from that, I feel like there's a certain symmetry there.
I agree with you completely, because it's actually a very neat formulation there, because actually what you're saying about the observer, it tightly mirrors what the situation the organism found itself in, which was a situation of surprise. In other words, I do not have a prediction for this. So whatever you do then is going to be surprising. I mean, initially, as I said, there's an element of randomness. This is not surprising. That's one of the repertoire of responses that the organism has, is stochastic behavior. What's surprising is that it's able to read the gradient of, this is a better direction than that. And so then you start seeing voluntary behavior. In other words, a behavior that you didn't predict. In other words, a behavior that's surprising to the observer. Yeah. And that's a voluntary behavior, and that's a novel behavior. It's no longer stochastic.
Sorry, go ahead, Chris.
I was going to say it also works in the sense of a behavior under uncertainty, when you're just sort of trying things out, that actually works, is both surprising and pleasurable. I mean, the case I always go to is tool use, because it's highly analogical, and you see it in lots of different organisms, and it's when a system is learning how to do tool use, like a young human is learning how to use their toy tools or whatever. It's a very pleasurable activity when it works, and it's very frustrating when it doesn't work. So it seems like a good kind of model system for thinking about this.
Yes. And in fact, and I love that because I bet we could engineer some kind of a cellular system and some sort of instrumental learning thing where the cell gets to do something and it works, it helps. So a tool use scenario, right? And could we measure some sort of a positive affect, or at least a reduction of stress, where it gets that, oh, look, I was able to make that happen. Great. Is there a primitive version of that we could detect in a cell or a tissue? Yeah, that give it a chance to learn something like that. And
yes,
paramecia are
that's the whole point, is to be able to come up with a agreed criterion, and then certainly then you can start doing exactly that. That's the whole point. Yeah. But just to go back to Chris's remark about surprise, well, both of your remark about surprise, I like that very much, because to me, when an affect is generated, it's always because of surprise, and the negative affect is things are going worse than expected. A positive affect is things are going better than expected, because remember, here this is random now. So the fact that this is reducing the need is a surprise, but it's a pleasant surprise. The fact that this works, you don't expect random behavior to work. You don't have high confidence in stochastic behavior. So it's a surprise in both directions, except it's worse than expected, better than expected. And then, the surprise reduces, and that's when you get to satiation. It's like, okay, now I know this works. It's no longer surprising, and I'm no longer in a state of uncertainty, and I've now got a new behavior that's at my disposal.
I love what you said earlier about this. Is it a generalization, or is it a mistake? Right, that something was, and I think that's very cool for two reasons. One, I believe maybe it was Dan Dennett, I don't know who it was, but somebody said that being able to make mistakes is a mark of agency, right? That chemistry doesn't make mistakes, but if you're an agent, but if you've made a mistake, that says a lot about what you've got going on, yeah, because you've had expectations. And
yeah, I agree. I would specify what's meant by mistake there is wrong choice.
Yeah.
In other words, it's only once you have the functionality of choice that you can speak meaningfully of mistakes in the sense that you're using the word now. If it was Dan who said that, in Dan's sense of the word, you can speak of, because if by mistake you just mean it did something stupid, it did something, it responded to stimulus A as if it was stimulus B and therefore died, is different from I responded to it as if it was stimulus B. That didn't work. So I'm now moving to, okay, I don't know what kind of stimulus this is. Let me try various things. Then you can make mistaken or not choices as you're going.
Well, and that strikes me as a, which I think is also good, as a continuum, because you can make really dumb, useless mistakes, and you can also make useful, sort of inspired mistakes, and everything in between, right?
Yeah.
And I think, and we deal with this in embryogenesis all the time. Like, what exactly is a birth defect, right? Is it an error by the, because one wrong shape is some other species perfectly good shape, and so, right, and so we think about this all the time, as these systems try to navigate that morphospace, when they make errors, error with respect to what, and then you start thinking about expectations, and some of these mistakes, of course, work out great, and some are random, and some are, exactly as you pointed out, more along a gradient of trying to improve things, and affect and all that. Yeah, it's sort of, okay, so that gets me into one of the things that I was gonna bring up, which is in this issue of expectations and so on. What do you think about, so in your talk, and of course in your book and everything else, you talked about kind of the intrinsically conscious properties of the parabrachial complex and those areas and all that. I'm curious what you think about, so let's say I extract it into the ex vivo culture system. So I've got this parabrachial complex. It's now living in a petri dish on our benchtop, and it's being fed. I wonder what you think about that aspect of it. Does it and whether I was trying to decide whether it would now think that it was in a sort of sensory deprivation tank kind of experience, or whether I don't know. What do you think about that? Once it's out of the body, does it maintain the special status that it had or not? Or what do you think?
Well, my answer to that is I'll give a very concrete answer to it, but I think there's a deeper principle that you're asking about. So my concrete answer to this particular instance that you're raising might not address the deeper principle, in which case, please say so, and then we can look at it again. And it's really a concrete answer. When I say that the parabrachial complex when I say actually that all reticular activating system nuclei are intrinsically consciousness producing nuclei, I mean, that is their function. Their function is to modulate precision, and in the ways that I was describing earlier, palpating of precision is an essential mechanism, as opposed to message passing in visual cortex. And that, when I say it's intrinsic, I mean the message passing in visual cortex doesn't need to be conscious. It only becomes conscious when it's modulated by reticular activating by reticular modulation. But now here comes the specific answer. The reticular activating modulation is that modulation of confidence, that palpating of confidence and adjustment of confidence is in response to what's happening in the periaqueductal gray. The periaqueductal gray is not part of the reticular activating system. It's as it were the other end of the cycle. So I'm acting up here, message passing. I'm doing this, and I'm sensing that in response. That's all modulated by reticular arousal, and then the residual error signal. In other words, I have confidence in this policy, but it results in this error. In other words, my confidence is misplaced. So periaqueductal gray, it's where all of these homeostatic, I mean, literally all of these homeostatic systems, they all of them ultimately deliver their residual error to the periaqueductal gray, which is adjacent to the superior colliculi, and on the basis of periaqueductal gray registration of the magnitude of the various error signals in relation to the current opportunities, it prioritizes. So the prioritization of an error signal is the feeling of the affect. It's so I've prioritized fear over thirst. So I feel fear. That is the prioritization of fear. So now thirst is going to be dealt with automatically. I'm not going to palpate my precision in my actions in relation to thirst. That's rendered automatic. I've now prioritized fear. And so I set about an action program that is designed to meet that fear. That action program, which is obviously it's the activation of long-term memories, which in other words, the expected, it's an action program with expected consequences. But these are expected precisions. And here I'm palpating, so it's not fixed precisions. I'm now palpating the precision in my policy, in my predictions, in response to to what extent do they or do they not deliver the sensory consequences that were predicted. So that's a long way of saying that what you can't really speak about what the parabrachial complex is doing as consciousness producing unless you link it to it's actually modulating what the message passing. That's what one type of consciousness it's producing is, and the other one is it's in relation to the periaqueductal gray consequences of that action cycle. So there's the feeling generated in PAG, and then it's the feeling this about that is the other aspect of the consciousness. So the parabrachial complex or any other part of the reticular activating system, if you just were to cut it out and put it in a petri dish, it wouldn't have that functionality unless it was in that loop.
Yeah, interesting. I always, we sometimes discuss in the lab what is the when you do have something like that sitting in a petri dish, what is the input? Is the input nothing? Is it because you still, the cells still have the sensors on them, they're still facing outwards, they're in the media, but is that is that the equivalent of turning everything off and getting no input, or is that the equivalent of getting sort of bizarre inputs that are surprising or because they're different than what you would get physiologically, or is it even possible to turn it off entirely, because you're always going to get some receptor, and if you get rid of the receptor, there's still some transduction machinery there, like there's always something. And the question is, what happens like in the sensory deprivation tank, you try to shut that stuff off, but it will immediately generate its own sort of simulator.
I think there's not going to be one answer to that. What would happen would depend on all sorts of imponderables, but of course something will happen, as you say. Yeah. But I want to just introduce one. Actually, again, I showed you in that brief talk in Boston at one instance of the sort of situation, although it's a small instance of the sort of situation you're describing, which is hydranencephalic children. So they have a reticular activating system, but there's no cortex to modulate. And so in what sense are they conscious? What they're conscious of is the errors. They're conscious of the feelings, but they don't know what the feelings are about. So they're still able to generate consciousness, and they're still creating a reticular activating response. But I'm not sure what that. Of course, we also simplify when we speak like I am now, because the reticular activating system doesn't only activate cortex. In fact, it activates all over the place, including spinal cord and and everything. It's just that the main destination by far is ascending, but there are also descending. There is also descending modulation right down. So it's modulating something, but it's not modulating the generating of, it's not generating conscious images.
Yeah, this is very interesting because we're discussing the role of a particular set of cells in error detection on the one hand and precision modulation on the other hand. But both of those sets of cells can also be considered to be active inference agents in their own right, living within some environment that provides them with inputs and responds to their outputs. And they have their own little models of how they expect their environment, which is whatever sends them inputs, to respond to whatever outputs they give it. So we're really working at two different levels of description here. And in the cutting it out and putting in a dish thought experiment, one has to characterize that environment, that quote normal environment, in situ environment of this little system very carefully to know how one would give it inputs and measure and respond to its outputs in a way that was close enough to its model that it would behave in something like the way that it's behaving in the body, or behave in some way that's intelligible to you as an observer.
Yeah, that's first of all, of course, you're completely right. You're right about, let us not forget that each one of these cells and each one of these nuclei have their own predictive model, and they're responding to their environment. So the interesting thing that flows from what you were just saying is, I don't do this kind of work like you guys, like you do, Mike, and you have done, Chris. I don't know to what extent is it possible to, in that situation, to start giving artificial inputs to the cell or to the nucleus, and you can start actually doing experiments to empirically address the sorts of questions we're discussing here.
Well, I mean, so totally possible. That was one of the things I was going to show you guys during the visit, and we never got to it because the worms sort of stole the show. But Wesley has these hybrids, right? Which, and many people have made different kinds of hybrids, which are brain structures, and for us also non-brain structures that are hooked up to artificial bodies. So people have published, you can take a lamprey brain and make it drive a little robot cart around by just basic, it's sort of taking sensory motor substitution and prosthetics and putting that on steroids and just saying, okay, instead of your normal artificial limbs, we're just going to give you new stuff that, new sensors and new effectors. And that works pretty well. I mean, there have been robots powered by slime mold and by fish brains and by I think they did frog brains and so on, and you can certainly do it, and we have some of that going on, and having artificial virtual reality worlds for a bunch of cells in a dish so that they can sort of inhabit that world, and certain things are rewarded and other things are discouraged and so on. I mean, what you get from that, of course, what we are able to collect from that is data on behavior and physiology. We're not able to get to touch first person consciousness, of course, right? Unless, and I think that will stay that way until and unless we sort of merge with the experiment, right? So at some point you'll sort of like, if you want to know what it's really like to be a composite system of whatever this crazy thing is in yourself, you plug it into your brain in some high high data transfer way, and maybe you'll have some experience of it. But so I don't know what it's like to be any of these agents doing their thing, but you can absolutely explant all these brain regions and give them, instrumentize them and give them artificial sensors and effectors, and they will act sensibly in these virtual worlds. So these hybrids will drive around and do various adaptive things that that they're being rewarded for, and so on.
I'd like to know what you guys think about this, but I don't want to. I'm going to keep it very brief because you got your list there, Mike. But what you are talking about, what we are now talking about, is of course the infamous problem of other minds. And if you go back to the beginning of our conversation today, where we, without being too exact and definitive, we seem to be in the region of some kind of consensus that sounds like a reasonable formal description of what a feeling agent would and would not be able to do when we were speaking about novel problems and novel solutions. I told you what I think the mechanism is whereby that happens. I told you what I think the mechanism has to be. It has to be the organism is registering its own state. It's registering its own state in relation to to put it formally, in relation to its free energy. In other words, is this increasing or decreasing the chances of me continuing to exist as a system? And it's only from its point of view. It doesn't have the same value to any other organism, because so the registering of that state is intrinsically subjective. The value only applies to that organism, and then it has to be within one of these categories of need. So it has to be qualitative, has to be qualified. So you've got a mechanism I've just described, which is simply just subjective and valenced and qualitative, registered by the system for the system. If that's the mechanistic description, then is that not just a description of a feeling? What else is that but a feeling? That's what a feeling is. A feeling is what I've just described. So, do we have to throw up our hands and say, well, problem of other minds, we can never know? Or can we approach it this way and say, well, once we've given a mechanistic description of what a feeling is, then we can see situations where such a mechanism is present and where such a mechanism is not present. We don't have to be the system. It's more, I think, a question of at what point is it justified to take the viewpoint of the system, to say that the system has a viewpoint at all. And then, if it's justified to take the viewpoint of the system, then you say, okay, well, if it's got this mechanism and it shows that behavior, then it must be feeling bad now and it must be feeling good now. It's what do you think of that?
Chris, you want to?
Is there no possibility of an objective criterion? That's, I suppose, what I'm saying.
Yeah, I think what that motivates, at least for me, is to try to understand in some phylogenetic lineage, for example, or looking at phylogeny as some sort of network of systems, how that assignment of affect is implemented in different kinds of organisms. Very, very simple organisms, for example. Things like worms or paramecia or what have you, where we have some chance of understanding a pathway that does this kind of precision modulation. And that's why I was bringing up the system in even E. coli, where, there is precision modulation. It seems like a bit of a stretch to interpret it in terms of feedback, but maybe it isn't,
Well, that's a very interesting conclusion, a provisional conclusion for us to have reached. And I will now defer to Mike's list.
Well, no, this is very good. There's only one other thing on the list, and that's pretty quick, I think. Just to, to speak to your last point, I think that's very interesting. And I agree with you that we don't have to throw up our hands and say we have no clue what the conscious state is. I think we can objectively make some good statements about that. But I wonder if that, so this, I think this goes back to the Mary argument, right, about the blind color scientists and all that, in the sense that, I mean, I think you can say quite a lot from that objective sort of perspective, but I wonder if that's really everything, in the sense that, does it really add nothing to then be the system and say, yeah, that's, so here's the system, and we've made objectively all kinds of conclusions about how, if it's happy or unhappy or whatever, and then magically you sort of become the system. And is your experience, well, yeah, I already guessed all of that, so nothing new here, or is it like, oh, now it's sort of much more, there's something added,
No, I don't agree with that, and I think that you don't either. So let me just say it. I think that to be, we're talking, let's say, for example, and we're engineering such a system. It's having artificial feelings about what is it like to run out of battery power. I mean, I've never been an inorganic system, and I've never had a battery, so I can't imagine what it feels like to run out. I can imagine, but I can't know what it feels like to run out of battery power when you're a robot that's got this functional architecture. But that's not the same as Frank Jackson's knowledge problem, because in Frank Jackson's knowledge problem, Mary, the visual neuroscientist, it's not only that she doesn't know what it's like to see, it's that her knowledge of how vision works makes no predictions that there would be something it is like to see. There's no necessity for there to be something it is like to see, but you can understand the whole physical mechanism of vision and leave out what it is like to see, and you've still got the whole mechanism. So this is in some parallel universe. What it is like to see, it's neither necessary nor predicted. Mary would never have expected that there is something it is like to see. In our case, the one we're talking about, we fully expect there will be something it is like from the viewpoint of the agent to be running out of battery power, and we can say it will be unpleasant, and we can say that the unpleasure will increase along this gradient that you can quantify, because it has to do with the decreasing confidence in the policy as it leads towards critical values, and so on. But the exact quality you wouldn't know, but it's way different from the position that Mary was in.
Yeah, maybe Lewis Carroll or somebody was saying that in order to transmit the feeling of I think fear, he was saying that to make someone feel scared, the thing to do is not to describe what that's like, but to actually provide some stimulus that actually scares them, to say something that would actually scare them, right? And so one kind of idea along this other minds thing is that the output of a proper, I mean, this has bothered me forever, is like what format in what format should be the output of a decent theory of consciousness? Like if we had a good one, let's say we had a good one, what does it output, right? Because most of our theories output numbers and things about observable behavior, but what does a theory of consciousness actually output? And maybe what it outputs is some sort of poetry or scary stories or whatever that literally try to put you in the same state that they're talking about. Yeah. So some kind of stimuli, some kind of scenario in which you get to experience, at least to some extent, right, as opposed to a sort of a scientific objective story about this is what it's about this, and it's linked to that, and positive and negative and so on. So that's why I was leaning on this sort of connection, because what I think it would output is protocols for, you want to know what it's like to be this, well, here's a protocol for putting yourself as close as you're going to get to the state that this thing is in, and then you'll know.
I think when you posed the question now, two answers occurred to me in terms of the output of a theory of consciousness. The second one is closer to what you're talking about Lewis Carroll's advice. The first one is more remote. It's got to do with the numbers. When you were saying, well, it won't be a system of numbers and so on. It's something else, because it's a theory of consciousness. I was thinking rather, actually, what it will produce is a system of numbers. Its output will be, I mean, I'm speaking poetically like you were, it will be a formalism. It will be algorithms and formalisms which underwrite those algorithms and all of that. But those formalisms will describe both the behavior of the organism, in other words, the external observables, and it will describe the internal states. So what is novel, what is the contribution of the output of a theory of consciousness is you'll have one formalism which will explain these tightly correlated variables, the physiological observables and the psychological observables. That's the yield, the scientific yield of a theory of consciousness. In other words, it does away with the mind-body dualism. It gives us a dual aspect monism, which is not a metaphysical one, but an actual, a natural scientific one. But to come to the second answer, which I think gets closer to what you're getting at, is that I think, and I don't just think this, I've experienced it. As I was working out my own felt uncertainty theory of consciousness, I started to have experiences that I hadn't had before. And those experiences were of the kind where I would suddenly realize, oh, that's why I'm feeling this now. This is not just something I'm subject to. It's not just a thing that happened. I know why I'm feeling this in response to that, and why my picture of the world is, I start noticing actually my picture of the world is not so continuous. There's sort of it's not, so I started to have different experiences which were yielded by the scientific account. But it wasn't that I started to have, it wasn't that I had feelings that I hadn't had before. It was more in the nature of I could understand my feelings in ways that I never had before. And that has consequences, but it's not whole new sets of feelings. It's more like thoughts that flow from the feelings that I hadn't previously thought. That's how I've experienced it.
Interesting.
So it is great. It is what you along the lines of what you're saying. It's sort of what you would expect, that a theory of consciousness won't only have objective consequences, it surely will also have subjective consequences. I think that's what you were saying, Mike.
Mm-hmm. Yeah. Okay. In the last few minutes, then one other question I meant to ask you. So we've talked about this before, and you mentioned towards the end of your talk here in Boston, the artificial agent that you're building and that your team is building. Is it going to sleep either by design or do you predict that as an emergent kind of feature? Is that something you guys have thought about?
Yeah, so we're really at a very basic level so far, so there's a hell of a lot to come. And as it happens, so we've gone through one phase of our study, and we're now starting the second phase of it. And the one of the main things we're trying to do in the second phase is making an environment which is better able to bring out and display the functionality. And we're also wanting to introduce multiple agents in the environment, so where the agents are having to predict each other's predictive models. And it just so happens that the needs that we're building into this agent, which are they're just ciphers. Because we're dealing with at this stage entirely virtual agents. It has a need for energy supplies. It has to find those resources in the environment, and the environment keeps changing. And it has to, while it's doing that, it bangs into things. and it has to not bang into things, because this is the equivalent of suffering tissue damage, and it needs to rest in order for the tissue damage to repair, which conflicts with its need to find the energy resources. So those were the reasons why we use those particular ciphers. Is we're wanting to create a situation in which the one need competes with the other need. So we theoretically have introduced something that functions a little bit. I mean, I say theoretically, more sort of like metaphorically, or in some way, we've created something which is analogous to a need to sleep. But I don't think it begins to tap into the sorts of things that you're getting at there. Because, for example, a crucial aspect of sleep is that the agent is no longer actually navigating an environment. It's no longer actually having to test its predictions against sensory consequences, because there aren't any sensory consequences, because it's not that, there aren't any actions that can offer any sensory consequences. That enables it now, being offline, being exempted from having to do that sort of thing. It's able to do a whole lot of other sorts of things, including memory consolidation. In other words, including the task, the very introspective task, for want of a better word, of attending to which of the new synapses or the new synaptic weightings that I established today am I going to retain, and which am I not? And this has increasing consequences the deeper you go into the predictive hierarchy. If something happens today which was not predicted by one of your most heartfelt beliefs, you're not going to just give up your heartfelt belief on the basis of one contrary bit of evidence. You need to really consider. And I think that this has a lot to do, by the way, with dreaming, which is, why does consciousness intrude into sleep if there's no problems to solve? Because you're no longer predicting anything about the world. I think it's a kind of housekeeping or a mopping up exercise that's best done offline, because you don't have any here and now problems to have to contend with. You can do this kind of really very consequential business of internally considering on the basis of an internal precision modulation exercise, whether to retain your old prediction or to update it when it comes to deeper levels of the hierarchy. So that kind of thing, it's when you're dealing with a complex system with a deep hierarchical predictive model, I think that kind of thing is very important. And it has consequences for a theory of consciousness because of what I just said about dreaming. So why must you lose consciousness at any point? In other words, why must you sleep? And why is sleep punctuated by dreams? I think that those kinds of questions can be addressed mechanistically in an artificial agent that has proper sleep, not the sort of toy sleep or rest that I was talking about earlier.
Yeah. Well, the reason, I mean, one reason I ask is because I have a postdoc that's very interested in sleep and unconventional systems, and so we've been thinking about how to recognize sleep in things that don't have the typical the obvious hallmarks, right? And so in planaria and paramecia, in our tissues, of course there's circadian rhythms and things like that, but the informational features that you're talking about now, the consolidation and all that, how do you besides simple inactivity, right? How do we Xenobots, do Xenobots sleep?
Yeah.
How do we recognize that? So I'm thinking about this whole spectrum from the truly minimal agent stuff.
Well, since we're out of time, it's a good moment to say we've come full circle, because my answer to that is one objective way of ascertaining whether or not the organism is asleep is if it's an organism which is capable of the sort of thing we were talking about earlier, generating novel behaviors, then during sleep that should stop, because that's an essential feature of sleep in terms of what I was saying just now, is you're no longer dealing with life's problems. You're no longer dealing with the external environment. You've withdrawn from it, so you're no longer acting on the environment. It really is, in many different senses of the word, definitional of sleep, that you're not producing voluntary behaviors. So I would say if you're talking about organisms that do display the functionality that we were speaking about earlier and calling that, voluntary behavior, I would say when that stops, if it stops for a phase of the, of the diurnal cycle, I would say that's its sleep phase. It doesn't, of course, have to happen only once, but if there's a protracted period like that, that would look pretty much like sleep to me.
Yeah, cool. Yeah. Well,
isn't it nice? There we see the benefits of having a more objective mechanistic definition rather than having to become the organism to know whether you're asleep or not.